So we are going to, in this section, look at the high voltage circuit breakers. Remember, we said earlier in the first section that we have two categories of circuit breaker for the purpose of this training. So we are going to look at the high voltage circuit breakers, and we said the high voltage circuit breakers, they are circuit breakers that operate in the voltage environment of above 1000. Okay, so under this high voltage circuit breaker, we are going to also have two different categories. That is the medium voltage circuit breakers and the high voltage circuit breakers. So we said the medium voltage circuit breakers operate between 1000 and 17,000 volts. That is 1000 and 1 to 70 kilovolts. Then the high voltage circuit breakers, anything that is above 70 kV. So if you look at your screen now, you will see this is the medium voltage circuit breaker, and this is the high voltage circuit breakers. So, but before we appreciate these circuit breakers that operate in the medium and high voltage environment, how they operate, we need to appreciate the mode of arc formation, okay, when a circuit is broken. Remember, earlier we said the function of the circuit breaker is to quench the arc, or rather to make or break the circuit while on load. And again, when the circuit is made or broken while on load, arc is bound to form. So the strength of that arc that is formed is dependent on the magnitude of current that is flowing through the circuit, and also to the magnitude of the voltage. So as you are moving towards the high voltage environment, the pressure, okay, that is driving the current is getting higher, which means that the strength of the arc that will be formed is also increasing. So as the strength of the arc is increasing, we need an effective quenching medium to put off that arc as it is being formed. So let us look at how these arcs, okay, are formed during the operations of the circuit breaker, or during the making and breaking of the circuitry. So we want to appreciate what happens. So to explain this, let us use this knife switch. Okay, so assuming that this knife switch is connected in line with the circuit, which means that the circuit is loaded. Okay, so as you are breaking this circuit, there is bound to be arc formation, okay, which you will observe as the knife switch is being opened. So you see, as it is opened, this is the arc that is formed. Now, this arc that is formed, there are some factors that influences the strength of this arc that is formed. One is the magnitude of the current that is flowing through the circuit, okay? Which means that the amount of load on the circuit will determine the strength of this arc. Not only that, the magnitude of the voltage, which is the driving force, the force that is driving the current through the circuit, as it is increasing, this arc will also be increasing. So what this tells us is that as you are moving towards the medium voltage and the high voltage environment, the strength of the arc, of the same arc, will be increasing. So we will need an effective means of putting off this arc as they are being generated in our circuit. So now, if you look at these two, this is a contact, and this contact is this is the low side of the contact, and this is the line side of the contact. Okay, which means that as you are loading the contact, current will be flowing through this contact to your line side. So if you are either making it or breaking it while on load, there is bound to be the formation of arc, which you will see as the contact is opened. So as this contact is open, this arc is generated. So this arc that is generated is a very high thermal event, okay, that is capable of ionizing the air between this contact. And as the air between the contact is ionized, it means that more conductive parts will be formed and that will sustain the arc. So we need to quench this because it has a lot of effects. Apart from the fact that it can destroy this contact, it also can help to maintain the flow of current on the other side of the circuit, which means that when it is open and you feel that you have opened the current will still be flowing through to the load side, okay? And that is dangerous for maintenance personnel. So as the contact is open, you see, because of the ionization of the air, the arc is sustained, the flow of current is sustained to the load on your circuitry. So these are not desirable conditions at all, okay? Because apart from the safety concern, it can also destroy these two contacts as we earlier identified, okay? So as you can see, these are some of the consequences of the arc formation. It can destroy the contact, the circuit breaker contact. And at the end of the day, we'll have the formation of metal oxide that will increase the resistance at the contact, okay? So remember that that arc as it is forming, it can lead to the oxidation of these metals, okay? So if your contact is made of copper, you find the deposition of copper oxide, which are heavy insulators, or if it is aluminum oxide on the contact. And those aluminum oxide or copper oxide, or rather all oxides of metals, they have very high insulating capabilities. And as the insulation at the contact is increasing from the effect of I square arrow, you will see that the amount of heat generated at the contact will also be increasing. That is not desirable at all for the operation of the circuit breaker, because it will eventually destroy the contact of the circuit breaker, and of course will also increase the losses in your system. So to prevent all of this, we need to look for a means to quench this arc before they are formed. Then on the safety concern too, you'll see that as it is breaking, like we acknowledged earlier, the air between the contacts will be ionized, and ionized air is highly conductive, okay? So the event is a very high thermal event, arcing event, a very high thermal event, and depends on the voltage that you are looking at. The pressure that will be created at the end of the day can cause explosion at the circuit breakers. So these undesirable event is what are the reasons why we need an effective means of quenching this arc. So the circuit breakers, the various types that we have that operate in the medium and high voltage environment, they are circuit breakers whose namings are informed by the kind of arc quenching medium they actually deploy as a circuit breaker, the program. So as you can see, we have the various types of circuit breaker. We have the air circuit breaker, the oil circuit breaker, the vacuum circuit breaker, and the SFC circuit breakers. So this naming, as we said earlier, is informed by the kind of arc quenching medium that is employed. Now, the first one is the air circuit breaker, which means that the arc quenching medium in this kind of circuit breaker is air. Okay, like the circuit breakers that we have seen earlier, or that knife switch that we saw earlier. You know that as you are opening it, okay, the arc is formed, but as the distance between the two contacts is increasing, the arc will eventually extinguish. So the medium that is helping us to put off that arc is air, okay, because that is the medium that is surrounding that contact at that particular point in time. So those are miniature circuit breaker that we saw earlier in this training, and the molded case circuit breakers, they are all air circuit breakers because the quenching medium is air. Okay, so now, like we said earlier, the air in itself has some dielectric strength. Okay, so which means that there is a distance you will separate the contact to. The dielectric strength of the air between those contacts will be strong enough to put off the arc, or will be strong enough to prevent the flow of current, okay, through the air. So here we have the air circuit breaker. This is an example of the molded case circuit breaker. Okay, so it's an air circuit breaker. So now the implication is this. Remember, we acknowledge that as the voltage is increasing, the driving force of the current will also be increasing. Okay, and also as the load on the circuit is increasing, the magnitude of the current that is flowing through will also be increasing. So the higher this magnitude of the current and the voltage, the more resistant the current will be, okay, to the breaking of its flow, which means that as you open up, the tendency of the arc to continue the flow or the arc formation will be very, very high. Okay, and as the arc strength is increasing, the capacity of it ionizing the air, destroying the dielectric strength of the air, will also increase, which means there will be a continuous path, okay, for the flow of electricity even after opening that contact. So we need an effective means of putting off this arc, okay, when it is formed in that medium or high voltage environment. Now we used air. The dielectric strength of air is a kind of small compared to some other medium. So now in this case, we are going to go to the second type of circuit breaker, which is the oil circuit breaker. So the oil circuit breaker employs oil, okay, to assist in doing the arc quenching. So the dielectric strength of oil is far, far greater than that of air. So the oil circuit breaker, the contact of the breaker is immersed or dipped, okay, or soaked inside oil, which means that the contact is surrounded by oil, mineral oil. So this oil, as the arc is formed, the oil is ionized. Remember, the oil, they are hydrocarbons, okay? So hydrogen is generated. This hydrogen gas that is generated conducts heat faster than air, about 8 times faster than air. So that will help to conduct the heat away, okay, from the arc as it is being formed. So that conduction of heat away from the arc tends to reduce the strength or the intensity of that arc, okay, and that will help to quench the arc. So, and once the strength of the arc is weakened, remember the dielectric strength of the arc, of the oil, okay, will prevent the flow of electricity or of current, as it is higher than that of air. But there is a drawback. Remember, we said the oil will be ionized, hydrogen will be liberated. Okay, so as you can see, that hydrogen that is liberated has the capability of pressurizing this tank. And with continuous pressurization of this tank, it can pressurize it to a level that it can result to explosion depending on the amount of arc that is formed. So as the voltage too is increasing, the amount of load that we have or we expect on the circuit is increasing, we need a more effective quenching medium. Okay, so from an experiment that was carried out by Paschen, the vacuum, okay, the dielectric strength of vacuum, as you increase the vacuum in a particular environment to a level, you see that the dielectric strength of that vacuum will just shoot up automatically. So at that level of vacuum, the dielectric strength is very, very, very high, okay, to prevent the flow of whatever current that is, okay, going to go through those contacts when they are open. So that is why it is deployed in medium voltage circuit breakers, okay? So you see the compactness of this medium voltage circuit breaker compared to its counterpart oil circuit breaker. So the dielectric strength of the vacuum, since it is far, far higher, that means we need a very small separation, okay, between the contacts to quench the arc and to put off, to stop the flow of current through the circuit. So the vacuum circuit breakers, they employ vacuum in extinguishing the arc that is generated when the circuit is being made or when the circuit is opened. Okay, so but there is a stage that you will reduce the vacuum to, and then when the vacuum is subjected to the high voltage, okay, as the voltage is increasing, there is that tendency of the formation of S-rays, which also will have its own safety concern. So for those very high voltage environments, you will see that the vacuum circuit breakers now have their own limitations. They cannot be used in those very high voltage and extra high voltage environment because of the formation of S-rays, okay? So for the high voltage environment, what is used is the SF6 gas as the arc quenching medium, okay? So how does it help in quenching the arc? So as a contact is opened or made and as the arc is forming, since it is a high thermal event, it will also dissociate or ionize or dissociate this sodium hydrofluoride into its constituent components, okay? That is element, that is sulfur and fluorine. So the fluorine gas that will be released also have a very high thermal conductivity, which means that it will tend to conduct the heat away from the arc, okay? And then as it conducts the heat, it becomes agitated and move away from the hot spot or the arc environment. Since it now has a very high kinetic energy, it will move away. And then as it's moving away, okay, as the temperature is going down, it will now recombine with the sulfur to form sulfur hexafluoride. So you will see that the SF6 breaker can comfortably handle very high current, okay? The only drawback in this type of breaker is that you need to maintain the pressure of the SF6 gas, because the pressure determines the dielectric strength, okay, of the gas. The higher the pressure, the higher the dielectric strength of the gas. So once there is leakage, that pressure, as it is reducing, that will eventually be reducing the dielectric strength of the circuit or of the arc quenching medium within the circuit breakers. So these are the various types of circuit breakers that we have in the high voltage environment. We have the air circuit breaker in the lower high voltage environment, okay? And you can use it between 1 and say 3 kV environment. Then we have the oil circuit breaker. So remember, the bulkiness is one of the drawback, okay? Because since hydrogen is created, ionization is there. You need the tank to be very big, okay, as the size is getting bigger. Then we have the vacuum circuit breaker. So let us look at these three circuit breakers in a little bit more details, okay? So now this is the air circuit breaker. Remember when we are looking at the miniature circuit breaker and the modeled case, this is a modeled case circuit breaker anyway, and it's an air circuit breaker. So this is the contact, this is the stationary contact, and this is the movable contact of this particular breaker. Okay, so as it is opening up, arc is formed between this contact. So the arc quenching medium here is air. The arc quenching medium here is air, okay? Because that is what we have between these two contacts as they are, between the stationary and the movable contact as it is getting off. So this arc that is formed, okay, is pushed into this arc chute. Remember, in our earlier section, we discussed the function of the arc chute, which is to help to extinguish the arc, okay, because as it is pushed into the arc chute, the arc is pushed into the arc chute. The arc helps to break it into smaller segments. So these smaller segments, okay, will have lesser strength compared to the full, that is the complete arc, and that will help to extinguish the arc, okay? So if this is your line side, it goes through the contact to your load side. So we have both the thermal and the magnetic operation mechanism attached to this end of the circuit breaker, okay? So this is the air circuit breaker. So here is the pictorial representation of the air circuit breaker contact, okay, and the arc formation and the arc chute. So now we have two contacts, okay, as you can see here. Then we have the main contact and the arcing contact, okay? This is the arcing contact and this is the main contact. So the arcing contact, when you are closing the circuit breaker, the arcing contact is made first, okay? And when you are opening the circuit breaker, the arcing contact opens last. The reason is this. The arcing contact is made up of, in larger circuit breakers, they are made of materials that you could easily replace, okay? While the main circuit breakers, they are made of more expensive materials that its replacement can cause the replacement of the entire circuit breaker. So we need to protect it from destruction, okay? So when the contact is when the circuit breaker is closing, the arcing contact closes first. So all the arcs that are formed is between the arcing, that is the main and the movable contact of the arcing contact, okay? So the arc that is formed here will be pushed into the arc chute and extinguished. Are we getting it? Then after the arcing contact has been made, okay, you see that current will flow through the arcing contact to your load. Are we getting it? From your line through the arcing contact to your load. And then when this main contact is closing, you see that since it is continuous here already, there will be no formation of arc on the main contact. Are we getting it? So once there is no formation, no arcing at the main contact, no corrosion, no deterioration, no destruction at the main contact. So, but if, on the other hand, that is conversely, if the circuit breaker is opening, assuming it's closed, when it's opening, it is the main contact that opens first. So once the main contact opens, since the circuit is still continuous through the arcing contact, no arc will be formed because the current will flow through the arcing contact. So it is when the arcing contact starts opening that the formation of arc will start. And as the formation of arc starts, the arc that is formed will now be pushed into the arc chute that will help to extinguish the arc. So most smaller circuit breakers like this may not have these two contacts, but this is a 100 amps breaker. But larger circuit breakers like 1,000, 2,500 amps, okay, they have both the arcing contact and the main contact. So you see them clearly on the movable, okay, and the stationary contacts, okay. So you see them very clearly on them. So that's the air circuit breaker. This is the arc chute, how it looks like when you lose it out of this molded case circuit breaker now. This is how it actually appears. So this is another form of air circuit breaker. This is a very big circuit breaker, okay, very big air circuit breaker, okay. So you see this is the movable contact, as you can see. So this is the stationary contact, okay, as you can also see. So you see that we have two contacts here, okay. This is the arcing contact and this is the main contact, arcing contact, main contact of this particular circuit breaker. So this is the line side to your load side, okay. So this line side leads to the stationary contact and the load side leads to your movable contact, okay, of the circuit breaker. And we have it attached to the operating mechanism. We are not going to go into that in this session, but all circuit breakers, they have operating mechanism. So we are going to look at factors that influences arc quenching. First is the distance between the contact, okay? So the farther away the contact travels, okay, the more likely you will extinguish the arc, because the amount of air between the contacts will be increasing, and that will increase the dielectric strength, okay, of the air between the stationary and the movable contacts, okay. Then another factor that will help to extinguish the arc is the speed at which the contact is opening, the contact opening speed. These are some of the parameters that you measure while carrying out maintenance, okay, on your circuit breakers. The distance, you measure the distance between the arc, the contact opening speed, and then you compare it to the manufacturer recommendations to see that they are still intact. So if the circuit breaker contact is opening faster than the arc is formed, of course, you'll see that it will help to extinguish the arc. Then thirdly, the rate of cooling of the contact of the arc also influences the rate at which arc would be quenched in the circuit breaker, okay. So this is an example. These are the arc chute for this particular circuit breaker that is 1 over the contact, so that whatever arc that is formed on the arcing contact is driven into the arc chute and extinguished.